Section 4.4 Graphs of Logarithmic Functions. In this section, you will identify the domain of a logarithmic function and graph logarithmic functions. Let's recall the domain of log function, like y equals log base 2 of x is, yes, it's 0 up to positive infinity. So we can see that on the graph below, we did this last time in section 4.3 when we used Desmos. The red graph is the graph of the exponential 2 to the x, and the blue graph is g of x is equal to log base 2 of x. And as you can see here, that the domain is from 0 to positive infinity. So that means only positive numbers. In general, there will always be a vertical asymptote. So for logarithmic, so we have a vertical asymptote here when we get close to the restriction of the domain of a logarithmic function. And that happens whenever the inside of a log approaches 0. Let's try example number 1. What is the domain of f of x equal log base 2 of x plus 3? Here, what's inside the log is x plus 3, or this is what you call the argument. And let's use that. X plus 3 greater than 0. So remember, approaches 0, and solve for x. We subtract 3 both sides. X is greater than negative 3. So domain is from negative 3 to positive infinity. Okay, let's have a quick check. What is the domain of f of x equal log base of x minus 2 plus 1? So again, what's inside here is x minus 2. So let's use that. Greater than 0. And solve for x. So what we do here is add to both sides. So x must be greater than 2. So domain is from 2 to positive infinity. So if you notice, we only use the x minus 2 part here, and the plus 1 here has no effect. Okay, let's try another example. What is the domain of f of x equals log of 5 minus 2x? So we have to set 5 minus 2x greater than 0. If we add 2x both sides, we get 5 is greater than 2x. And divide both sides by 2. So we have 5 halves is greater than x, or you can say that x is less than 5 halves. So domain is from negative infinity to 5 halves. Okay, let's have another one. What is the domain of f of x log base 6 of 4x minus 3 minus 5? So let's set 4x minus 3 greater than 0. then add 3. So 4x is greater than 3. Then divide both sides by 4. And you will have x is greater than 3/4. So domain is 3/4 to positive infinity. So again, if you notice that this minus 5 has no effect. Okay. Alright, next, let's talk about the graph of logarithmic functions. The graph here is the parent function f of x log base b of x. Is it 1-to-1? So using horizontal line test, yes, it is 1-to-1. Vertical asymptote. As you can see here, in green, we have vertical asymptote when x is equal to 0. What is the domain? So we talk about this. The domain is 0 and 0 to positive infinity. What is the range? As you can see here, this graph is to negative infinity to positive infinity. Is there an x-intercept? So we have a point on the x-axis here. So yes, that is at 1, 0. We have a key point at B1. Do we have a y-intercept? Since you have the vertical asymptote at x equal to 0, meaning there's no point on the y-axis, so there is no y-intercept. And it's increasing on from negative infinity to positive infinity. Okay. Alright. Example number 3. Graph f of x equals log base 5 of x. State the domain, range, asymptote, and x-intercept. First graph this, we know that we have an x-intercept at x equal to 0, and this is the graph, whereas you have the x-intercept at 1, 0, and you have a key point at 5, 1. So remember, y is equal to log base 5 of x, and we write this to exponential, that is 5 raised to y is equal to x, and 5 raised to 1 is equal to 5. So that's why we have that key point here at 5, 1, your x and y. Alright, so what is the domain? Domain is, yes, from 0 to positive infinity. Range, yes, from negative infinity to positive infinity. Do we have an asymptote? Yes, we have the vertical asymptote. That is x is equal to 0, and x-intercept is at 1, 0. Okay, next one. Transformations of logarithmic functions. All of the transformation rules that we've learned before apply for logarithmic functions as well. Example number 4. Sketch a graph of f of x equals log base 2 of x plus 2 minus 3, and then state the domain, range, the asymptote, and the x-intercept. Let's start with the graph. Here's the graph of log base 5 of x. We did this earlier. So from the given, x plus 2, that means 2 to the left, and minus 3, that is down 3. So this is our log graph. We move this 2 to the left and down 3. So we move this 2 to the left. Now your vertical asymptote is at negative 2. So let's think about if you move this point 2 to the left, down 3, we have a point here, and this point 2 to the left, 1, 2, down 3, 1, 2, 3. So this will be our graph. So this is log base 5 of x, and this is the given log base 5 of x plus 2 minus 3. So again, what we did here, left 2 to the left and down 3. Okay, example number 5. Sketch f of x is equal to log base 5 of x. Its vertical reflection g of x equals negative log base 5 of x, and horizontal reflection log base 5 of negative x, all on the same graph. So let me start again sketching log base 5 of x. Here's the graph of log base 5 of x. You see that x-intercept at 1, 0, and we have the key point here at 5, 1. And next is the vertical reflection. G of x, negative log base 5 of x. So think about vertical reflection. So you will have a point here at 5, negative 1. We have the vertical asymptote at x equals 0. Oh no. Here's the graph of negative log base 5 of x, and that is the vertical reflection of log base 5 of x. Next one, horizontal reflection, log base 5 of negative x. So here at 1, 0, we're gonna have at negative 1, 0, 5, 1, and we will have a point at negative 5, 1. So the graph will look like this. So this is the log of negative x with a base 5. Okay, all of them has vertical asymptote at x is equal to 0. Again, this green. Okay, so again, these are the three graphs. The orange, log base 5 of x. The red is the vertical reflection, negative log base 5 of x. And the last one is the horizontal reflection of log base 5 of negative x. Okay, And then let's try some problems here. For the following exercises, state the domain and the vertical asymptote of the function. So remember, what we do here is set what's inside of your log or ln greater than 0 and solve for x. So let's say if we add x both sides, meaning this is 3 is greater than x. So with that, the domain is from negative infinity to 3. And vertical asymptote is, yes, x is equal to 3. G of x is equal to negative ln of 3x plus 9 minus 7. So again, 3x plus 9 greater than 0, and we can subtract 9 both sides. So 3x is greater than negative 9. Divide both sides by 3. So that is x is greater than negative 3. So our domain is, yes, from negative 3 to positive infinity. And since x is greater than negative 3, so our vertical asymptote is x is equal to negative 3. Next, for the following exercise, state the domain, range, x and y intercepts if they exist. If they don't exist, then you can write does not exist D and E. So 24. F of x equal to log base 2 of x plus 2 minus 5. Let's start with x plus 2 greater than 0. Then if we subtract 2, x is greater than negative 2. So with this, you can say that domain is greater than negative 2, so that is from negative 2 to positive infinity. What else? Range is, yes, from negative infinity to positive infinity. This is true for all log functions. For the range. Next, x and y intercepts. So remember, how do we get our x and y intercepts? Let's start with x-intercept. That is when y is equal to 0. So 0 is equal to log base 2 of x plus 2 minus 5. Solve for x. We add 5 both sides. Log base 2 of x plus 2. Then we can rewrite this to exponential. So remember the arrows. 2 to the 5th is equal to the argument x plus 2. And 2 to the 5th is 32 equals x plus 2. We subtract 2 both sides. So x is equal to 3. So meaning your x-intercept is at 30, 0. Okay, then next one, y-intercept. Sorry, I'm going to use this space here. Y-intercept, that is when x is 0. So y is equal to log base 2, plug in 0 to x, plus 2 minus 5. And that is y equals 0 plus 2 is 2 minus 5. And recall log base 2 of 2 2 raised to x is equal to 2. What is that exponent? So that it's equal to 2. 2 raised to 1 is equal to 2. So meaning this is equal to 1. So y is equal to 1 minus 5. So y is equal to negative 4. So your y-intercept is 0 and negative 4. Okay, so we get again the domain, set x plus 2 greater than 0, solve for x, that's negative 2, so that's negative 2 to infinity. The range is for all log functions is always negative infinity to positive infinity, or all real numbers. Then x-intercept, set that is when y is 0, solve for x. So plug in 0 to y, and then you can rewrite this to exponential form. So 2 to the 5th is equal to x plus 2. 2 to the 5th is 32. Subtract to both sides, x is equal to 30. And that's why x-intercept is negative 30, 0. Then for the y-intercept, that is plug in 0 to x, y equals log base 2 of 0 plus 2 minus 5. Log base 2 of 2 is equal to 1 because recall this, log base 2 of 2 is equal to what number? And when we rewrite this to exponential, 2 raised to x is equal to 2. What is that number? Yes, that is equal to 1 because 2 raised to 1 is equal to 2. So that's why this whole thing here, log base 2 of 2 is equal to 1. So 1 minus 5 is equal to negative 4. So the y-intercept is 0, negative 4. Okay, and that's it for section 4.4. Again, if you have any questions, please let me know. Thank you.